Welcome to the last unit of the course, which is Chapter 8 in the textbook. Today's lesson is 8.1 and 8.2. Hopefully a lot of this is a review from grade 7 and 8 math. If not, you'll be learning it today. 8.1 is all about the Pythagorean Theorem, which is named after a Greek philosopher and mathematician, Pythagoras. So he proved that when dealing with a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the two shorter sides. So our hypotenuse is always opposite to the right angle and is always our longest side of our triangle. And we always use variable c to identify the hypotenuse. So in the formula, c is always representing the longest side. Now, a and b in the equation are the legs of the triangle, or the other two sides of the triangle. Okay, so hypotenuse is the longest side, and then the legs are the two shorter sides. So how you label A and B doesn't really matter. In the diagram, A is here and B is at the bottom, but B could be here and A could be here. That's fine. What can't be changed is C. C is always the hypotenuse, the longest side. The reason why A and B can be interchanged is because if you look at the formula, A and B is being added together. So A squared plus B squared is the same thing as saying B squared plus A squared. Okay? But what doesn't change is the C. C squared, or side C, is always the hypotenuse. Okay? And the Pythagorean theorem can only be applied to right triangles. All right, so let's practice applying the Pythagorean theorem. So here we have a right triangle, and I know it's a right triangle from the right angle. And it's asking us to find the unknown side length. So here, the side length that's unknown is already labeled as C, which is perfect because that's our hypotenuse. It's opposite to the right angle, and the hypotenuse needs to be labeled with C. So I'm trying to find the hypotenuse. So my formula is A squared plus B squared is equal to C squared. Okay, so again, it doesn't matter which one is A, which side is A or B. So I'm just going to go ahead and just label it like so. And now I'm going to plug in what I know. So I know that A has a value of 12. Okay, and I know that B has a value of 9. So I'm going to simplify 12 squared, 144. And I'm going to simplify 9 squared, 81. Okay, so before I add 12 and 9 together, I use BEDMAS, which says that exponents must be simplified before adding together. So the 12 had to be squared and the 9 had to be squared before we added them together. So I did that here, 12 squared and 9 squared, and now I can add them together. All right, so now we know the value of C squared, which is not what I'm looking for. I'm looking for what C is. So I need to use opposite operations here. So the opposite operation of squaring is square rooting. I'm going to square root both sides. And that square root sign and that squared is now going to cancel each other out. So on my right side, I'm left with C. And the square root of 225 is 15 meters. Let's try again. Here we have another right triangle. This time we actually know our hypotenuse. So opposite to the right angle, this is our hypotenuse. And then I'm just going to label this as A and this as B. And so we can also write our formula in this way as well. Okay, so a squared plus b squared equals c squared, or c squared equals a squared plus b squared. I know my hypotenuse value. I'm trying to find a, and in the diagram it's labeled as y. So I'm just going to sub y for a, and then we know that b is 5. 13 squared is 169. I still don't know what y is. 5 squared is 25. I'm going to bring my 25 over, and it becomes its opposite operation. And simplifying my left side. And again, the opposite of squaring is square rooting. So another way of doing it is just bringing that square over to the other side where it becomes square root. And the square root of 144 is 12. Okay, let's practice the Pythagorean theorem in a word problem. A 14-foot ladder is placed 6 feet away from a wall. So this ladder is 14 feet long. So it's leaned up against a wall. The distance from the ground straight up to the top of the wall is 13 feet. So from here all the way to here, floor to ceiling, 13 feet. Will the ladder reach the top of the wall? Okay, well, the diagram gives us a little bit more information. So from the wall to the floor, that creates that 90-degree angle. Let me try again. Here we go. Okay, so this is a right triangle. So from the bottom of the ladder to the base of the wall, it's 6 feet. And then opposite to the right angle is our hypotenuse, or the length of the ladder. Okay, and so the question is asking, will the ladder reach the top of the wall? So we're trying to figure out what this distance is here. Let's label this with B. This is A, this is C. From the diagram, it doesn't look like it's going to make it, but let's just make sure. Okay, I'm going to sub in what I know. And then I'm going to simplify my squares. And then I'm going to isolate for my variable. So B is equal to approximately 12.6 feet. Okay, let's go back to the question. It says from floor to ceiling, the wall is 13 feet. So the ladder is just under 13 feet. So since the wall is 13 feet high and the ladder only reaches 12.6 feet, the ladder will not reach the top of the wall. Okay, let's try another word problem. Diana is flying a kite while standing 60 meters from the base of a tree. Okay, so let's draw the tree. Diana is over here and is standing. I'm going to use a ruler for this so it's a little bit neater. 60 meters from the base. So the base of the tree to Diana is 60 meters. Her kite is directly above the tree. Okay, so her kite is over here. Here's her kite. She's flying a kite. It's directly above the tree. And it says that the tree is 10 meters tall. So the tree is 10 meters tall. And she's holding the string that the kite is attached to, and it's 130 meters fully extended. So when the string is fully extended, it creates that straight line. So she's holding the string that's attached to the kite and it's fully extended. Okay, so we've created a right triangle. Hopefully you can see that. And here is our right angle. How many meters above the tree is the kite? So we're trying to find this distance right here. What is this? Okay, so we know from the ground to the top of the tree is 10 meters, but we don't know the distance from the top of the tree to where the kite is. So I know that this is my hypotenuse, and this can just be my A, and this whole side here can be my B. Okay, I'm going to start off with my Pythagorean Theorem formula. Okay, and I'm going to plug in information that I know. Okay, so the total side B is approximately 115.3 meters. So that is a whole side length. So from the ground all the way to the kite of the kite, this whole side length is 115.3 meters. So just to find what's highlighted here in black, this portion of that side length, what I'm going to do is I'm going to take 115 and I'm going to subtract the height of the tree. What's left over will be how much above the tree the kite is flying. So 115 subtract 10, 105.3 meters. Therefore, the kite is 105.3 meters above the tree. Okay, so there are some homework questions from 8.1 that you can try there. Let's move on to 8.2. And this is all about perimeter and area, which hopefully you've had a lot of experience with. Now, specifically, this is the composite figures, which are made up of more than one simple shape. So right here, we have, in example A, we have a rectangle. Now we can split it up into a simple shape, which is a rectangle. And then we also have a right triangle. Okay, so composite figures are simple shapes that are combined together to create a composite figure. Okay, so in order to find the area or the perimeter of composite figures, you have to divide the composite figure back into its simple shapes. Okay, so let's practice doing this. So the first example is determining the perimeter. So remember, perimeter is adding up all the exterior sides. So we're missing this side length right here. And so in order to find that, we need to divide this composite figure into simple shapes. So like I just did, I'm going to divide this into a rectangle and into a right triangle. So to find this side length here, this is actually our hypotenuse. So I can use the Pythagorean theorem, which we just learned, to find side C. So I'm going to, step 1, use Pythagorean to find C. A squared plus B squared equals C squared. Okay, so this could be my side A. So side A is, well, this whole side is 22. And from here to here is 14. So just to get what's highlighted in green, I'm going to take 22 and subtract 14, which is left over is that highlighted green part. So my A is actually 8. And my B, which is this purple side, is the same side length as this, so 12 centimeters. Okay, 8 squared is 64. 12 squared is 144. 64 plus 144 is 208. The square root of 208 is approximately 14.4 centimeters. Okay, now in step 2, I can find the perimeter. Okay, so a reminder, perimeter is the exterior sides. Okay, so the exterior sides of our composite figure, this side plus this side plus this side plus this entire side here. So that purple line that I created is not included. It is not an exterior side. All right, so we found the perimeter of this composite figure. Let's try one more. All right, so here, there's already a dotted line that divides this composite figure into simple shapes. So we have a rectangle here, and then we have a semicircle here. On our online classroom, you will find a formula sheet that will provide you with the circumference of a circle. So this is the formula sheet that you'll find online on D2L. And here is a circle. So instead of saying perimeter, we say C, or circumference of a circle. The circumference is the perimeter of a circle. Okay, so it's here. C is equal to pi times diameter. So to get the semicircle, we would just divide this by 2. So remember, the diameter is the length from one side of the circle to the other, and the radius would be half the diameter. So we're trying to find the circumference of the semicircle. So I'm going to use the circumference formula. To find the perimeter of the semicircle. Okay, so circumference is equal to pi times diameter, and now I'm going to divide it by 2 because we're only interested in half a circle. Okay, circumference is equal to pi times Okay, so if we extended this to be a full circle, this right here would be your diameter, which is the same length as the side of the rectangle. So our diameter is 12 millimeters. Okay, and hopefully you all have scientific calculators. So instead of typing in 3.14 times 12 in your calculator, I want you to use that pi button times 12 on your calculator. Okay, it does make a difference when you're typing in 3.14 than when you're typing in pi. Your answer is going to be not as accurate if you type in 3.14. So just something for you to be aware of. Okay, so now we've found the perimeter or circumference of that green line. Okay, so now we can find the perimeter of the entire composite figure, okay, by adding the green line and the red line together and the two blue lines, which are both 24. Okay. So the next two examples are the exact same composite figures as example 1, but this time we're going to be finding area of composite figures. Okay, so area, remember, is everything inside a two-dimensional shape. Okay, so it's this, we would follow the same steps. We would divide our composite figure into simple shapes, then find the area of each simple shape and then add them together. So let's find the area of the rectangle, or area 1. So the area of a rectangle is length times width, which is length times width. It is not 22 centimeters. 22 centimeters is from here all the way to here. Okay, so we're not using the 22 centimeters. We're using 14 centimeters. 14 times 12, 168. And remember, area, your units are squared. So let's find the area of the second simple shape, which is a right triangle. And that is equal to base times height over 2. And again, if you don't know that, it's on the formula sheet. Okay, so in a right triangle, your base is here and your height is here. So they're always the adjacent sides or the connecting sides of the right angle. Okay, so never the hypotenuse. Your base and your height are always connected to that right angle. Okay, so your base, this value right here, we're going to take 14 away from 22. So 22 subtract 14, 8 centimeters. So our base has a value of 8 centimeters, and our height is the same length as this side, so 12. 8, 12, 2. 96 over 2, 48 squared centimeters. Okay, so to find the total, area total, we're going to add area 1 and area 2 together. Okay, let's practice again. All right, so we have area of a semicircle and area of a rectangle. So area 1 will be our rectangle. So the length is 24 and our width is 12, 288 millimeters squared. Area 2 is our semicircle. Okay, and again, you can go and reference the formula sheet for area. Okay, so this first column, that's your perimeter. Now I'm going to read the second column, which is our area. I'm going to go down to a circle. So area is equal to pi r squared. Okay, so now this time I want my r value, which is half the diameter. And now because it's a semicircle, I'm going to divide my formula for area by 2. So pi r squared over 2. So pi, now I need an r value. So from here to here, it's 12 millimeters. So that's my diameter. So r is equal to diameter over 2, 6 millimeters. Okay, so I'm going to multiply 36 by pi. So I'm going to simplify my numerator, 113.1, and then I'm going to divide it by 2, which is approximately 56.6 squared millimeters. Okay, and again, my total area is equal to my 2 areas added together. All right, one more page. So steps to determine the area of a shaded region. So sometimes you don't want to find the area of the total composite figure. You just want the shaded area. Okay, so I just want this right here. So what you're going to do is you're going to find out the area of the entire composite figure. Then you're going to find the area of the non-shaded part, and then you're going to subtract it from the total, and that'll equal to just the shaded region. Let's practice. So I'm going to find the area of the entire large circle. Okay, the area of this whole thing, the entire thing, that's what I'm looking for. So area of a circle is equal to pi r squared. So my radius from the center of the circle all the way to the exterior, the very exterior circumference is 14 centimeters. $14 squared is 196 times pi is 615.8 centimeters squared. Okay, and now I'm going to find the area of a smaller unshaded circle. So this one right here, the unshaded circle, what I don't want to include. Okay, so I found the total area. Now I'm going to find the area of the unshaded circle and then subtract it from the total. So area, again, of a circle is pi r squared. The radius of the unshaded area is 7 centimeters. Okay, so now I'm going to take 153.9 away from my total area to find the total, to find the area of the shaded region. Okay, and then finally we have this other composite figure. Pretty much everything is included except for this square right here. Okay, so I'm going to find the area of, I'm going to divide this. So this is going to be one rectangle. I'm going to find the area of this whole rectangle, including this unshaded region. And I'm going to find the area of this rectangle. And I'm going to find the area of my unshaded region. Okay. So area 1, area 2, area 3. Area 1, length times width. Or for a circle, side squared. 2 squared, 4 centimeters squared. Area 2, length times width. 5 times 3. So 5 times just this part, which, so from here to here is 10 centimeters, and from here to here is 7 centimeters. So this part right here is 10 subtract 7, which is 3 centimeters. And then area 3 is 7 times 3, which is 21. Okay, so then the area of shaded region. So area 2 and area 3 added together, but then I'm going to subtract that unshaded square. Okay, and we're done. Again, there's some practice questions here for you to try in the textbook, and then completing today's quiz. If you have any questions, please message me.